Good evening, geometry students. We are continuing in chapter 10. We are in section 10-3, and we're going to talk about the area of regular polygons today. This is going to be something quite different to what you've seen before, so we'll take it a little bit slow at first, and then we'll really start diving in. So what I'd like for you to be able to do is to find areas of regular polygons by identifying the necessary variables in order to do that. So I want to remind you guys of what a regular polygon is real fast. A regular polygon, which is this part in our definition, it has all congruent sides and all congruent angles. So this formula that I'm showing you and all this stuff I'm showing you today is only going to work if you have regular polygons, which means all the sides are congruent and all the angles are congruent. Now right here we have an image of a regular hexagon, and it is inscribed in a circle. So we're going to use this image to kind of help us identify what these vocab words are. So the center of a regular polygon is going to be the center of the circumscribed circle. So essentially it's just the very, very middle, and it's going to be equidistant from all the vertices of your shape. Now we have two different lines projecting from the center. A line's going to the vertex or the corners, and then lines going to the center of the side. Those are two different things. The radius is a line that goes from the center to a vertex. So a line from the center to the vertex. And this is called an apothem. An apothem is a line from the center to a side. Now there's a couple things you should know about that. It goes to the middle of a side, and it's going to be perpendicular. So meaning it meets at 90 degrees. So notice this line right here is an apothem. It's going from the center to a side, and it meets at 90 degrees. So I'm going to label that stuff in this image now. So this point right here is what we would call the center. So I'm going to label that. And this, well, there are many radii drawn on this right now, but I'll just identify one. Something from the center to a vertex or from the center to a corner of the shape, that is called a radius. But if it goes from the center to an edge or to a side, then that is called the apothem. So I'm going to label that for you as well. That is the apothem. Now, because this is a regular polygon, we're going to be able to find lots of values within them, and I'm going to show you how to find center angles right now. So it says calculating angle measures in regular polygons. We're going to find the measure of angle 1, 2, and 3 in this regular polygon. Because this polygon is regular, that means all of these angles in here are going to be congruent. So what I can do, I can say, okay, well, all the way around would be a circle, so that's 360. So to figure out what one of them is, I'd take 360 divided by how many parts there are, or how many sides there are. So I'm going to take 360 divided by 3, and that's going to get me 120 degrees. 120 degrees is what angle 1 is, because angle 1 is from here to here. So I'm just going to say 120 degrees is equal to the measure of angle 1. Now, something that's nice is we know that now all of these others, like from here to here, that's also 120 degrees, or from here to here, that's also 120 degrees. Now, this apothem right here is dropped in, and it's cutting that angle into 2 halves. The apothem is cutting the angle in half, and it's cutting the side in half, so that's pretty convenient for us. So to figure out what the measure of angle 2 is, I'm going to take what the measure of angle 1 is, 120, divide it by 2, and that's going to get me 60 degrees, and that's going to equal the measure of angle 2. Now I need to figure out what the measure of angle 3 is. Well, I can easily use the fact that the 3 angles in a triangle add to 360. So if I focus in on this triangle right here temporarily, then I can say, oh, I've got a 90 degrees, a 60 degrees, and then what's that one going to be? So I can say 90 plus 60 plus, I'll just say x is equal to 180. And when I do all that, I am going to get 30 degrees is equal to the measure of angle 3. Let's do that again. So we have a regular pentagon here, and I'm going to try to find the measure as angle 4, 5, and 6. The measure of angle 4 is just going to be 360 divided by 5 because there's 5 sides and all of these central angles are going to be the same measurement. And if a full circle is 360, a fifth of that would get me angle 4. So I'm going to take 360 divided by 5, and when I do that, I'll check my work just in case in the calculator. I get 72. So 72 degrees is what the measure of angle 4 is. So that's this whole distance from here to here, which means the whole distance from here to here is also 72. So to figure out what angle 5 is, I'm going to take 72 and divide it by 2. So 72 divided by 2 is equal to 36 degrees, and that's the measure of angle 5. For my last angle, which is angle 6, I'm going to focus in on this triangle right here in order to find its value. I know angle 5 is 36 because I calculated it right here. Right here's a 90-degree angle, so I can just use my triangle angle sum theorem. So I'm going to say 36 plus 90 plus x is equal to 180 degrees. When I add these up and subtract them from 180, I am going to get 54 degrees. Awesome. So I'm going to have 54 degrees is equal to the measure of angle 6. We have one more example. We are finding the measure of angle 7, 8, and 9. This is a regular hexagon. So to figure out what angle 7 is, which is just one of the central angles, I'm going to take 360 and divide it by how many sides there are, 6, and that's going to get me 60 degrees. So 60 degrees is equal to the measure of angle 7. So from here to here is 60, but also from here to here is 60. Also from here to here, and from here to here. All of those little individual angles are 60 degrees, and if you add them all up, you'll get to a full circle. 8, on the other hand, is cutting that angle in half because of this apothem. So I'm going to take 60 degrees, divide it by 2, and that's going to get me 30 degrees. So that's the measure of angle 8. Measure of angle 8 is just half of the whole angle right there. Now, if 8 is 30, then that means this angle over here must also be 30. So I can kind of use the fact that these are congruent triangles to figure out what angle 9 is. So I know this is a 90 degree, and I know that that's 30. So I know that angle 9 has to be 60 degrees because it's forming a 30, 60, 90 triangle. So this is how we would calculate angles inside of a regular polygon. And that's going to help us a little bit further down the line. But for right now, let's move on to area of regular polygons. So far we've talked about the radius, the apothem, and the center. That's all this stuff. Then we talked about angles that can be formed in a regular polygon. And now, how can we find the area of a regular polygon? area is going to equal 1/2 the apothem times the perimeter. And I'm going to label these letters so you know. So capital A means area, lowercase a means apothem, capital P lowercase p means perimeter. So let's flip this page over and work a couple problems. We're going to start with example A, or example 2, part A. It says find the area of a regular decagon with a 12.3-inch apothem and 8-inch sides. Okay, so I'm first going to write my formula. Area is equal to 1/2 apothem perimeter. I know what the apothem is. It tells me the apothem is 12.3, so I'm going to say little a is equal to 12.3. Perimeter, on the other hand, is not 8. Perimeter is just one side. So that side is 8, and this side is 8, and this side is 8, and all the way and so forth. All of these are the same length. So if I have 10 sides, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and they're all 8, then the perimeter would have to be 80. Now I know my two values that I can put into my formula. So I'm going to say area is equal to 1/2 times 12.3 times 80. Definitely going to need a calculator for that one. And that gets me 492. And we're working with inches, so I'm going to say inches squared, or square inches. We're going to skip example B and go down to example C, just because we'll be doing that other one in our notes during class time. So that says find the area of the regular octagon. We're doing example C here. All right, here we don't have as much information. We need to determine, is it the 13 or is it the 12 that's the apothem, and we're going to have to figure out the perimeter. So let's first write our formula. Area is equal to 1/2 apothem times perimeter. We can easily figure out the apothem. It's either the 13 or the 12. So if you need to, go back to your definitions up here. Notice how a radius goes from the center to a corner. The apothem goes from the center to an edge, and it's forming a 90-degree angle. So on this one, which one of those lines is going from the center to an edge? It's the 12. So my apothem is the 12. Now I gotta get a little smart about this perimeter. I know that the apothem is cutting this opposite side in half, so I can say, okay, that side is congruent to that half. And if I can figure out what this half is, then I can figure out what the whole is. And if I can figure out that side, then I then know all the other sides. I can add them up and get the perimeter. But how on earth are we going to find that side? We are going to use the Pythagorean theorem. We're going to focus in on that right triangle, and we are going to use a squared plus b squared equals c squared. So the 13 is the c because it's the hypotenuse. Make sure you don't get that mixed up. I'm just going to come over here to the side, and I'm going to say 12 squared plus b squared is equal to 13 squared. Well, 12 squared is 144. 13 squared is 169. Now I'm subtracting 144 from both sides. I'm getting b squared equals 25. Square root both sides. b equals 5. Cool. So what this means is this half over here is 5. From here to here is 5. So to figure out the total length of one side, of just one side from here to here, that would be 10, because 5 plus 5 gets us 10. That is not the perimeter, though. The perimeter is the distance all the way around. So I've got 10, 20, 30, 40, 50, 60, 70, 80. This is an octagon. That makes sense. So the perimeter is 80. Now we're going to take these values, stick them into our formula, and we're almost done. So area is equal to 1/2 times 12 times 80. You might need to use your calculator for that. And I'm getting area is equal to 480, and we don't have a unit, so I'm just going to say units squared. And there we have it. We're going to do this last problem in class as well, so that's all that I'm going to show you in this note video. Have a great night, and I hope to see you soon.